everyone. Thank you for coming to our hideously ugly space. This is our first Axios COP events, series of events. So I really appreciate you guys coming and taking part in these discussions. So I'm Andrew Friedman, Senior Climate Reporter with Axios. I cover the climate negotiations and the sprawling sort of side event ecosystem that's sprung up this year. Tonight we're exploring AI's role in decarbonization and what opportunities and challenges lie ahead. Joining me first for a panel discussion is Beta Technologies founder and CEO, Kyle Clark, and UPS Executive Vice President and Chief Corporate Affairs and Sustainability Officer, Laura Lane. There's water for you over here that is appropriately labeled, and maybe for you over there. So welcome to Axios House.
Thanks.
Thanks for coming. Kyle and I have a long history of missing each other whenever he's in DC, sometimes by minutes, sometimes by an hour or so.
And mostly your fault, just to throw
almost always my fault. It's almost always my fault, and so it just makes sense that we traveled across the world to actually meet tonight. So just looking at these cue cards with my questions, which is kind of funny. So I'm just gonna wing it because I don't think they're on here, which is fun. But I have lots of experience in improv comedy, so this is gonna go well. So my first question is really general, and I do want to encourage both of you to talk to each other. You both know each other through professional purposes.
Kind of partners.
Yeah, and are kind of partners in rolling out electric aviation for cargo applications. So my first question really is how your company is respectively using AI or potentially thinking about using AI in your operations.
So we are already using AI in our operations because we've got to be thinking about the now and the future. And so we use a lot of predictive analytics in terms of figuring out where we need to be closing gaps in emissions reductions. And it's in the course of using AI to develop our network of the future that we've created this great partnership with Beta, because we know one of the biggest challenges that we have is on reducing our emissions in the air. Just to give you context, UPS is unfortunately a big emitter of carbon. We emit 33 million metric tons. We're on a downward slope, and we're very committed to creating as many efficiencies as possible in our network. But we have the challenge of the air operations, where there aren't a lot of innovations or technologies or solutions right now that we haven't already utilized in our operations to lower the carbon footprint. In fact, 65% of our emissions come from the air, and without ubiquitous supply of sustainable aviation fuel, we've got to be figuring out how to double down on innovation in this space to get more carbon out, as we also lean into creating the demand signals for more production of sustainable aviation fuel. Enter the fabulous company that is Beta, where we said, is it possible to come up with this idea of electric aviation for the cargo space? And when we met Beta, we said, hello, this is the answer to part of the solution that we need to be operationalizing across our network. And it's through the use of generative AI that we have develop these ideas about the network of the future and the kinds of solutions that we need, then include the solutions that Beta is going to be delivering.
Yeah, So from my perspective, we're a hardware company. We make electric aircraft, battery-powered electric aircraft that are ever increasing in range. The longest, people ask this question all the time, the longest we fly the airplane right now is about 3 hours, 330, 340 nautical miles, which is a meaningful enough distance to make a dent in what Laura described. So our role is actually to be the physical manifestation of the data science, that when we look at data science in a predictive way, that's AI. Or if it's trained on a data set that allows you to make better decisions, it's using AI to use a vehicle in this case that has done something pretty magical, and that is it's flipped the capex and the opex equation on its head. Historically, aviation was driven by operational expense, mostly fuel. You take the fuel out, the recurring cost of operation goes to near nothing, and all of a sudden it way opens the aperture on the use cases. And as your colleague and boss, Carol Tomei, said to us so early, she said, wow, this enables us to sweat the asset. And the next question is, how do you sweat the asset? And I think that's where the data science and the AI comes in.
In terms of running, so you run obviously an electric aviation company. Your scope 3 emissions may not be a huge challenge like it is for UPS. How do you find that you're tackling that at UPS? And is AI for either routing purposes or anything else in how you're thinking about your delivery network helping to make you more efficient and maybe leapfrog into some new technologies?
So we've been tracking our scope 1, 2, and 3 emissions since 2002. But with the use of generative AI, we've been able to create certain planning tools and route optimizations that have helped us minimize the number of miles traveled, both in the air and on the ground. And the idea is that with these applications, including with sometimes when we contract with outside service providers who represent some of our scope 3 emissions, we're able to optimize their routes as well, because we like to plan the end-to-end route that any of the packages take, whether they're in our network or we've handed them off to someone else. And so we see incredible opportunities to just travel less miles, have our partners travel less miles, and ensure that the emissions per package is reduced. And in fact, in our goal to get to carbon neutrality by 2050, our goal is to cut the emissions for every single package that travels in our network or in a partner network by 50% by 2035. That's going to take a lot of that generative AI and that those capabilities that come from the tools that run off of it to help us drive those kind of reductions.
And Kyle, when people think of electric aviation, I suspect that most of them think of like an eVTOL taxi type thing that picks them up at a Wall Street heliport and takes them, to their private jet. You guys have a very different way of thinking about this, and your use cases are very different. And that's where you're finding synergy, and I can't believe I just said synergy because it's such a business buzzword. But with what UPS is looking for and what other cargo carriers are looking for.
Yeah, thank you for bringing that up. So when people think electric aviation, they think air taxi. And unfortunately, air taxi, although it's going to happen, is 3 or 4 steps down the road. Our thesis, and it's shared by UPS, is that cargo goes electric and vertical before passenger does. But more importantly, cargo goes autonomous before passenger does. And I don't think that's a big leap. When you take the cost out of the fuel first and then you take the pilot out, again, you're reducing those recurring operational costs of the aircraft, and then you can really exploit what you just said a minute ago, which is optimization of routing. In our world of autonomous, which is really reliant on some pretty sophisticated models of decision making, AI being a very big tool in this, We have inward-looking AI. What do you do when something goes wrong inside the airplane, and how do you manage the system? And outward-looking, how do you deal with cooperative, non-cooperative weather systems and other things? Now, when you put a human in the loop, the human wants to do something, just like the astronaut effect, right? They are the worst landers of the moon, but it turns out they're the ones that are pulling the lever just to give them something to do. So we take the pilot out, we take the problem out in many cases, and we allow ourselves to exploit optimization or routing, which is, in my opinion, the biggest untapped efficiency gain after you get electric. And it's evidenced over and over again. You know, somebody wants to get home on a Friday night, they push the throttle up. That's what happens. That's a reality, that you burn twice as much fuel. The most expensive from an energy perspective mistake is a missed approach. Like, you can be really efficient in all the stuff you do all through the whole flight. You miss the approach, you come around, and you go again, and all that efficiency is thrown out the window, right?
Yeah.
Or you don't thread it right, and you end up, you don't have your deconfliction, what they call terminal area clearances. AI and autonomy solves that, and the efficiency goes through the roof.
And I just want to pick up on that because we're already using drones in our operations. In fact, we've been using drones in sub-Saharan Africa for delivery of vaccines and healthcare products. But they're smaller payloads, right? And that's where we want to go to what Beta is going to be able to make available. That's 1,400 pounds.
I guess we didn't even talk about this. The reason that I think this is so big, no pun intended, is that it's not a drone, it's not an air taxi. This is a 7,000-pound aircraft
bigger.
that carries
better.
4 shipping pallets of stuff,
Yes.
a meaningful distance.
Yes.
And that means when we look at this, 65% of the emissions come from the airline. We don't get to hit everything day one. But UPS taught us about this thing they call the mesh network of the future, which is no longer this radial network, and it requires data science and predictive analytics to say we can connect these city pairs with meaningful package densities, and we can do it at a low recurring operational cost, not with little drones, but with stuff that goes from here to CK full of stuff, like a big amount of stuff.
And the biggest unlock for us is going to happen when it doesn't go from airport to the location. It's when it can go from facility to facility, creating greater efficiencies in our operations, gets us away from all the congestion that we often have to deal with at the airports, gets us away from all the extra handling that has to happen, because any way that we can deliver packages with minimizing the number of handles, the better. And the eVTOL makes that possible when we go facility to end consumer.
I know
beautiful.
we're nearly out of time, but I just have to share one thing that I think is really important. It's that sustainability can't stand on its own when it's not economically viable in this type of, and I'm pushing outside of my expertise, in this type of application. About 4 months ago, UP and us partnered on flying one of our aircraft with the equivalent amount of weight that was on a fueled aircraft all around Manchester, New Hampshire, doing the same routes. It ended up being 30% of the cost of the existing technology.
And lower emissions.
And zero emissions.
Zero
effectively.
emissions, that's right.
It's just like you have such, you win on both fronts, and that's why we're so invested in it.
What was the comparative aircraft that you used? Was it a Caravan?
It was a mixed aircraft, so they flew Twin Otters, Embraer 110s, both twin-engine turboprops. Compared to a Caravan per mile, which we have a lot of experience in, it's about half the total cost. But the energy cost, and I'm talking total cost, pilot, insurance, all that stuff. When we look at the energy, and this is something we do all the time, I fly Cessna Caravan 208 as a chase pilot and fly ALIA. We've flown it all over the United States. We just flew it to Florida and measure every single leg that we do. It is $17 per fill-up in our aircraft, and it's $700 per fill-up in the Caravan.
It's a slight difference. I mean, I'm not really good at math.
You know, it nullifies that massive delta when you add the insurance and the pilot and all that kind of stuff. But you've taken the fuel cost and you've gone boop to nothing.
You know, I just kind of wanted to let that answer reveal that you're a pilot. But my one fun thing question, I think, is for Kyle, which is, how does one go from playing hockey for the Washington Capitals organization to developing and heading a successful, electric aviation company that now has its own factory in Burlington, Vermont,
Which, by
and
the way,
expanding.
is the largest net zero building east of the Mississippi now.
I was going to say that,
facility.
but
Yeah, right. So how does one do it? First of all, the name Beta was my nickname in hockey because I was the nerd on the bus, always programming or designing airplanes. And I was just always building airplanes. And Beta was my senior thesis at Harvard University now 20 years ago. And finally, it feels like we're starting to get the right traction to make a difference in the world 20 years later.
Well, we're out of time. I went a little over time because I think you guys are both doing incredibly interesting things. I actually think that up next, we're going to hear from our publisher, Nick Johnston, and one of the main sponsors of this event, which is IBM. Thank you.
Up next, our View from the Top moderator, Axios publisher Nicholas Johnston.
Good evening. I am Nicholas Johnston, the publisher of Axios. As Andrew said, nothing that we do at Axios is possible without our partners, and so we have a huge debt of gratitude to IBM for helping make this happen. Tonight is our very first day, very first events ever in Dubai and next to a COP. Before you leave, make sure to check out the cool IBM installation on AI right behind you. That'll be here all week, and of course, who better to have as my View from the Top guest today than a resident expert on IBM's AI efforts. He's a Senior Vice President of Product Management and Growth, my good friend, Dr. Kareem Youssef. Dr. Youssef, welcome back to Axios. So let's start big picture. What is AI's role in all of this? What are you doing here all week as an AI scientist? What role does it play in decarbonization and addressing climate change?
Well, actually, it's really about gaining insights from data. When you really think about solving the sustainability problem, it comes down to making sense of all that is being done. And that means you have to kind of gather it up, drive the insights, and then drive actions based upon that. So we actually do a lot of work around AI applied to sustainability data analysis.
So this is like understanding the state of climate, understanding possible remedies, and figuring out what works and what
One of the
doesn't.
very examples themselves, yes.
So this is interesting. When we last spoke at the Axios AI Summit in San Francisco a few weeks ago, I asked you the coolest thing coming in AI, and what you were most excited about was spatial recognition.
Geospatial.
Geospatial, which is, I guess, understanding all the data around the Earth. And when I'm thinking about that here, that's a climate answer, right?
Right. Now, for all of you, the context was we were talking about large language models, and everybody thinks about asking questions. And he said, what else am I interested in AI? And I said, something not connected with large language, geospatial analytics. So the work we've been doing with NASA, I mentioned that to you before, with the geospatial foundation models, are helping us do things like actually locally here work on urban heat maps, right? Doing work on forest fires, flood, climate risk analytics. Yeah, it's using AI to gain right insights.
And is the real solution here in that the amount of data we have is just massive? Satellite images, photos, all kinds of sensors, and a scientist looking at it could spend millions of years trying to make sense of it. How does AI accelerate that?
Look, AI superpower is decision support when you really step back from it, right? You're really trying to leverage it to enable decision support, which means making sense of massive amounts of data, deriving those patterns, guiding through, and supporting action. So that's how it comes together.
So let's dig into a couple points specifically on decarbonization, and what the AI role can play, because I think this is very new certainly to me, and to I think probably a lot of people out here with us. Let's start with sustainability regulations. How would I deploy AI on that?
So if you think about the problem of regulation, the first thing is gathering data around what you're doing. Think simple energy utilization. You've got everything from as simple as grabbing information from your energy bills to determining what's in your scope 3, which could be buried all over in things like invoices, purchase orders, and the like. So AI can help there with making sense of all that data, doing what we call extraction from things like invoices, helping to normalize all the weights and measures, and putting it into a format that allows you to actually begin to assess where you are and then therefore effectively report against compliance.
And so now, what is that? Without AI, what does that look like? Or is it you can't even
It's
process as much information at
well,
all?
One, it's extremely manual. Right now, a lot of folks are dealing with lots of spreadsheets, right? Extremely manual, no verification of data, not capturing all the data they would like to capture. And so it's really about bringing the rigor that you would expect in financial systems to the very notion of sustainability data.
And because this is unstructured data, you mentioned financial data. Financial data, it's in an Excel spreadsheet. The kind of data you're talking about is just
It's all over. With there is structured and a lot of unstructured. It's also not all captured in single or well-known systems.
So let's move to the next thing on my mind, and that is the energy transition to renewable power. Tell us how AI as a tool would work for that.
A lot of our clients are focused in on optimization. How do you effectively run wind farms and solar farms, as an example? Also think about asset maintenance, asset lifecycle management. So think of these windmills. Think of them like turbines. You have to understand how they're performing. You have to operate them in the optimal way so that you can keep them performing. This is true in any power generation activity and is applying more and more as we look at this transition.
Is, again, I think similarly to the regulations, it's applying an AI system to this unstructured data set. The efficiency of a windmill to how much the wind is blowing.
Exactly. All the data coming off, both how the equipment is doing, what are the environment conditions, right? In the regimes in which it's operating. And you begin to hear things like predictive maintenance as an example, as one of those kind of key use cases that bubble up.
So we are saying the word data a lot,
Right.
and data runs in data centers, which are notorious for energy consumption. How can we help solve that problem?
Well, two key dimensions. One, think about the operation of the data center itself. So you hear us talk about things like green IT. That's about optimizing the kind of workloads and how they're being deployed. It does speak to the machinery, so optimization of servers and chips in their own right, making those more power efficient. And it also does speak to the techniques that we use. So one of the things around foundation models, as I told you last time we spoke, you're learning from massive amounts of data. Coming up with techniques that allow you to do that more efficiently and more effectively is also key to doing that in a more sustainable way. And using renewable energy to power those data centers as well.
Like these all things fit together. But
They
then I
all
guess
do.
the last question is somewhat related to that, is that AI itself is very energy intensive on those data centers. Like, can you ask an AI to be more efficient?
Well, that's kind of
Maybe a simplistic way of doing
no,
it.
but yes, no, that is kind of part to your point. So, to the point I was making, how can you run the data center more efficiently in self-service in terms of the equipment? How can you power that data center with more renewable energy? And how can you improve the AI algorithms in their own right to be a lot more efficient and compact? These are all the areas of exploration.
Do you have a sense at this climate summit that the climate people are hearing the AI people talk, understanding what the possible resources they have to sort of check off all of those boxes that you just mentioned?
I actually think they are. I mean, one of the most powerful things I think about COP is how it brings people from a very diverse set of backgrounds, walks of lives together to actually have this conversation. I would definitely say that we're seeing this transition to more action-oriented discussions and thinking, right? Everybody's going, what do I do? What do I do right now? And key to understanding the leverage of AI, and especially your last point about this point of energy versus not, is the transparency. Can we measure what it's doing? Do we understand what is going on? And can we make that effective?
I mean, this is maybe an opportunity for a lot of people in the climate movement. This is their first meeting with someone who maybe does AI for a living, who can finally tell them what they're not even thinking of asking, right?
Well, I think so too. I mean, take vegetation management as just another classic use case example. Many people would not realize how much money utilities spend managing vegetation around power lines and the like. And
I
you
did
can
not
use
think of that until you just mentioned it,
Right,
but
and
now the light bulb goes.
Now you can use AI to really optimize by understanding soil conditions, climate, weather conditions, and the actual vegetation to come up with better optimizations where to go do work first.
Even this is almost coming up here, walking around, just helping them think of questions to ask that you can then help them.
That's once again the power of bringing people from diverse backgrounds together.
Great. Well, this is, as I mentioned, Axios' first time in Dubai. And before we leave, I want to end on one fun thing, one Dubai thing. This is also your first visit to Dubai?
It is indeed. Although I've passed through the airport more times than I can count.
All right, first time out of the airport in
First
Dubai.
time out of the airport.
Now that you've escaped the terminal, what is on your bucket list to do while you're here?
It's all about building. So I'm a civil engineer by training. And for me, I mean, I'm fascinated by the architecture, by all the buildings around. I got to get to that large one. What's it called? Burj
Al Khalifa,
Burj
I
Al
think,
Khalifa.
yes.
There you go.
I have my ticket.
Yep. So I got to get that, and it's going to be all about buildings for me. Buildings and spaces.
I'll see you at the top floor. Thanks again, Dr. Youssef. Thank you to IBM also for making today happen.
Pleasure. Thanks, Dick.
Welcoming back to the stage, Andrew Friedman.
Thank you. Thank you to Nick and to IBM as well. Hi again. Our next guest is making waves in the climate tech industry, but especially in a very specialized portion of that industry, which has a direct application to the climate negotiations that are taking place right now. Please welcome the executive director of Watt Time and the co-founder of Climate Trace, Gavin McCormick. Welcome. Thank you for coming.
Thanks. It's good to be here.
So, can you tell people just a little bit at first what Climate Trace is, and maybe just a snippet of what you think are the most important thing that you guys announced in the past couple of days? It's a lot, so.
Well, Climate Trace is a global coalition of about 100 collaborating nonprofits, universities, and tech companies who are all experienced in two things, AI and emissions data. And what we've essentially done is to team up to build Wikipedia-like, a giant shared database of anything any of our different algorithms have been able to use AI to find about emissions. And so what we have now built is a single unified global database that measures more than 325 million sources of pollution around the world, estimates their emissions from space, and makes that publicly available. So that means that we are closing in on a comprehensive view of all sources of greenhouse gas emissions in the world. Who is causing them? We are tracing them back to their sources. And we released yesterday a large public open database where anyone can go in and see not just what are the emissions of China, but what are the emissions of the factories in China. And we are also able to do this for a lot of countries, including the UAE. So one of our interesting results is that a lot of countries' inventories, here we are at the Global Stocktake, are quite old. And we were able to update new information, including finding some facilities that were not finding their way into inventories. So we've been able to find about 3 billion tons of emissions that appear to be missing from various countries' inventories. So I would say the most interesting thing we've been able to find is sources of emissions that were not previously known.
Yeah, and that's absolutely key when you are going forward on trying to make targets and goals for countries, when countries are making national pledges, and whether or not they're trustworthy. What I guess I wonder is, before we get into a few more AI details, is where you see this going. Because what you're providing is essentially something that we didn't anticipate having when Paris was negotiated not too long ago, which is an actual way to monitor CO2 emissions and other greenhouse gases down to the facility level, down to the smokestack you might see outside your hotel room or, in your community, for example. And what I wonder is, as putting a policy hat on, is whether or not that allows you to evolve into a enforceable agreement or a name and shame type of agreement where you put pressure on countries and pledges who are, not meeting up to their pledges. And I wonder if you, as the co-founder of this, are thinking that way, or if your mind is so focused on like the technical aspects that it's more policy geeks like me that are wondering where they can take it.
Well, one of the interesting things about Climate Trace is we didn't all start out as AI experts. We started out as people running nonprofits who had very specific use cases where if we could get XYZ data, we have actors who say they would be willing to cut emissions. So for example, I started as the power plants lead, and we know quite a few companies who are aware that if they time, say, an electric airplane or an electric vehicle or a smart thermostat to different moments, some moments power grids are cleaner than others. But they needed some global way to say which times are cleaner than others. We also talked to a number of corporations who are large steel buyers, and they said, we know there are clean steel facilities out there, but we don't always know which ones they are. If we could just know who to buy steel from, we could know which facilities are cleaner. So a lot of these use cases are now live. So for example, several of the world's largest car companies announced yesterday they are going to be using climate trace data to be finding cleaner sources of steel. Several of the largest renewable energy buyers in the world have announced they're going to be using this technology. But all of those are very positive applications. And so I would say, yes, there is potential to use this data to find what are things missing in country inventories, what are the people whose corporations are now emitting more than the legal limit. But I actually think the more exciting application of AI is figuring out when there was a genuine misunderstanding and when data points to a solution that can reduce emissions that actually no one's opposed to. Anytime you have to catch a bad guy, there's going to be a fight. Anytime there's a cost, there's going to be a fight. But when you can find sources of emissions reductions that no one knew about, and we think we've already found over 1 billion tons a year of reductions that have no catch, those kinds of things can happen very, very fast.
Yeah, no, that's fascinating. 1 billion tons a year that you could make that's sort of low-hanging fruit in a way. Now, what kind of applications for AI have you really applied to this process in a sort of systemic way?
So we're best known for computer vision. So the easiest way to start with the global emissions inventory is to look at satellite imagery. So the first sort of most obvious use case was let's go train satellites to spot where do we see CO2, where do we see methane? Okay, what factory is that next to? The next step beyond that is what are the visible spectrum signals that emissions is happening that are not actually emissions? So I'm really interested in if you actually look for steam coming out of a power plant, you are going to get a more accurate indicator of emissions than if you look for emissions themselves. Why is that? Because AI is very good at figuring out if I find some signal that's easier to measure and is well correlated with the ground truth data, I know it does or does not predict the ground truth data accurately, regardless of whether a human would have guessed that is true. So we've now combined many forms of computer vision, but a lot of them are not in the human visible spectrum, like thermal infrared. Great way to figure out if factories are emitting. Then we started using natural language processing, and we're now in the middle of upgrading to generative AI to search through text. So I'll just give you one example before I move on, which is that it's very common that a trade journal will say that a steel factory is being constructed, and no corporate reporting will mention its emissions. It is conspicuously missing from all databases on emissions. But an AI algorithm can figure out that we have a 500 megawatt boiler going in at this facility, and we have a good sense now of where to look for emissions. Those combine very nicely.
Yeah. No, I wouldn't have thought that you had figured out sort of applications for generative AI quite yet. Also, what has made Climate Trace so successful? I mean, usually alliances of disparate groups, especially nonprofits, and large alliances, you know, I don't want to say herding cats, but like, this is not a normal thing to happen among nonprofits. Most of them hate each other and compete. It's the same thing with scientists. Whenever anybody tells me that climate change is a global scientific conspiracy, I'm like, have you talked to scientists? Like, they cannot plan anything together, let alone carry out a global conspiracy. So what is it that has made you guys so successful in such a short period of time at tracking this stuff, at putting it out there in ways that people can use for different purposes? Yeah, like I'm really curious, like what the X factor has been.
I think there's a couple of them, but I think the most interesting one is the one you alluded to. It's very uncommon for nonprofits to collaborate well, and I think what's missing is actually very simple. It's incentives. I'm actually an economist by training. It's very unusual for a person like me to be running a tech project. But what I sort of started with, and my colleagues really started with, is why don't we avoid the mistake of the 20 previous nonprofit coalitions that attempted the exact same project, all of which don't exist anymore? And all of those did the same thing. One group said, right, we are in charge. Everyone else, give us all your data, because everybody knows that AI is better when you share it, and we will run everything, thank you very much. There was absolutely no reason anyone would say yes to that deal. Climate Trace has no CEO, has no board that can issue orders. All it is a protocol for organizations to say, we want these data, we are willing to share this in exchange. And what we figured out is the fact that every single organization in Climate Trace gets something out of it, and a large number of them are measured in specific concrete use cases where at the end of the day, a government or a company actually reduces emissions. That kind of product thinking is very common in the for-profit sector. But if your product is emissions reductions, we can all win. And so I think what has made Climate Trace special is those donating data, those doing AI algorithms, those doing the comms, we all agree on the goal, and we've made sure that everybody wins rather than a everyone supports me dynamic.
Yeah, I'm shocked that the top-down leadership model didn't work. When you were talking, I'm like, this just sounds like a weird Sam Altman sort of story with a nonprofit board and a for-profit company, and we saw that play out over the last couple of weeks. And lastly, what do you think made such a natural partnership to get Al Gore involved in this? We have him here tomorrow, so maybe I'll ask him the same question. But I was especially curious because, you know, Watt Time and some of these other organizations are ones that, you know, a lot of people haven't heard of. And yet he jumped in, had his name associated with it, and really seemed to accelerate your work.
Well, one thing I did not know is that Al is a lot better at AI than I would have guessed. So I will never forget this story. I walked into his office the very first time as a representative of a small nonprofit that had just gotten a small Google grant to do a couple of us teaming up on electricity emissions. I had invented a new algorithm that morning, and I had emailed it to him, and by the time I got to his office, he had suggestions for improvements. And it blew my mind to be meeting with a politician who could not possibly have read this anywhere because it was fresh, who actually had suggestions on how we can improve our AI algorithms. And what I learned is that since the 90s, he has been waiting for someone to finally have advanced enough technology to be able to use satellites to monitor emissions all over the world so we can finally put to bed this old story where emitters can say whatever they want, and our primary mechanism is self-reporting. And so for many years, he had been on the lookout for any project like this that had a chance of breaking through. And so I would say we were a bunch of people running very tiny nonprofits who had no intention of creating a project this big. It was really his vision that supercharged it.
That's good to know. That's all the time we have for today, Gavin. But I've been following you guys very closely since you emerged on the scene, and you guys should really be paying attention to what Climate Trace is doing and using that data however is best for your organization, but not from a top-down management structure, because that does not work. So thank you very much. And up next, my colleague Naila Budu, who's a host of our One Big Thing podcast.
Hey, everybody. So thank you so much for being here. We have two more guests before we wrap up our first day at Axios House here in Dubai. We've been having such interesting conversations about AI, and I want to welcome John Powers, who's going to join us for our next one. He's the Vice President of Global Clean Tech and Renewables at Schneider Electric. Welcome to Axios House.
Thanks. Good to be here. Thanks for having me.
Beautiful breeze for you now. So I wonder, we've been talking and hearing so much about AI across all of these different sectors when it comes to renewable energy. How are you all using AI, and how much of it is generative AI?
Yeah, that's a good question. So Schneider Electric, our mission is to be the digital partner for our clients on sustainability and efficiency. So electric, right? Schneider Electric, we're definitely energy focused. So a lot of cool stories and ideas about forest fires and other ways to use AI. Our focus is definitely on the energy side. And so it's, it's machine learning and a little bit of the generative AI large language models. So, Schneider's one of the leaders in connected devices, Internet of Things, edge control, management systems, et cetera. But we're also one of the largest advisors, energy and sustainability advisors to large multinational corporate and industrial clients in the world. And so in both those applications, we've been using AI for a number of years, but on the future, there's, I think, even more exciting possibilities and horizons.
So when we're thinking particularly about the semiconductor industry, you recently launched a program that's aimed at getting semiconductors companies to invest in decarbonization industries?
Yeah, so one of the things we talked about on a previous panel was how do you keep the AI, what goes into the AI, the semiconductor chips, the data centers, if that's producing a ton of carbon, all of the things you can save are sort of, outweighed. So one of the programs we've launched with Intel and Applied Materials is an aggregated program for the semiconductor industry to measure the emissions from the supply chain of the semiconductor industry and find ways to reduce those specifically through renewable energy solutions.
So after COP27, you said that public-private collaboration was key and that it could lead to faster changes, particularly when we're thinking about government-led initiatives. How much progress do you think there's been towards that here at COP28?
There can always be more. One of the things, by representing so many large electricity users, large energy users, we see that there's never been a higher demand for sustainability solutions, for renewable energy solutions in the private sector. And we'd love to see more governments give the option for corporates, for private investment to go into renewable energy, to go into sustainability solutions. We find when you remove the barriers, there's an absolute flood of interest and investment. So
when you say option, you mean?
So, for most of our clients, we're helping them with renewable energy sustainability solutions in markets that are deregulated, that have choice. Where can you actually source your energy from? So the US or Europe or Brazil or Australia, Japan. But there's a lot of markets where you don't have that choice at all. And so we have customers with load in Vietnam or Indonesia that really want a solution, and there's not a lot of optionality there. So that's really one of the things we see that governments can do is just give the private sector a role to play, and they'll step up and make an impact.
Do you find that depending on the country you're in, there's sort of a different culture of thinking about AI and how much you want it to have involved in the work that's happening?
Yeah, I'd say there's different amounts of trepidation about AI in different markets. But the ways that we're using it is really things like microgrids, right? So Schneider Electric has a variety of microgrid hardware and software solutions that we're running, and you can optimize that with AI. It's machine learning. How do you make sure you're charging the battery at the right time of day, using the solar panel at the right time of day, discharging the battery? So we've been doing that for years. We've also been looking at, if we're managing people's global electricity use, there's hundreds of thousands of electricity bills, gas bills, et cetera. There's going to be gaps in that data. So how can you train the machine to fill those gaps with the right data and the right numbers so that you can identify hotspots and know this is the facility I want to target, this is the outlier, this is where I'm using more energy. So a lot of those use cases a little less threatening. I am asking our CEO to approve my PTO by faking his voice, deep fake, and it's working great.
It's
but
been working
yeah,
great.
Other than that, yeah.
You're going to be here a little longer than just a
Yeah.
couple of days. So we talked about public-private partnership, particularly governments making it easier. What are 2 or 3 things you hope to see from COP28 when it comes to policies for advancing renewables?
Yeah, I think the biggest, as I said, I'd really like, as we think about the policy, let's not leave the private sector out of it. In the US in 2022, 70% of the renewable energy that was built was financed based on the private sector, voluntary long-term purchases of renewable energy from corporate and industrial buyers. Only 30% was because of government mandate. And so just giving the option and maybe removing some of the subsidies for some of the fossil fuels, the levelized cost of energy for renewables is already less expensive in most markets around the world. So if you just level the playing field and give people the choice, the market's going to run towards renewables, and we're seeing that in markets where it's possible.
Getting back to AI, I just want to end on one last question about whether or not you think we need to have a reality check in terms of the limitations of AI in this space.
Yeah, I was in an interesting roundtable this morning, and speaking about AI, and it's really, it's not all about the algorithm, right? There's the algorithm, and that's part of it, but it's really how do you use that algorithm, what are the applications, and then how do you train the people to use it, right? If you've got a great algorithm, but no one in your business is using it, then you're really not going to get that far. So it's limited by the adoption and the use cases, and it's still going to take people to train it, to use it in any of these applications.
Well, unfortunately, that's all the time we have for today, John. Thank you so much for joining us.
Thank you, Neela.
Our final guest is Dr. Fahad Al-Yafi, the Chief Technology Officer of Siemens Energy Technology and Innovation Center in Abu Dhabi. Dr. Al-Yafi, welcome to Axios House. Thank you for being here.
Thank you. Thank you for having me here.
So first I should ask, what's it been like to have 70,000 people here in the UAE for COP28?
Yeah, not only for COP28, but also for the National Day. So
Can
2
you,
days ago was
yeah.
2 days ago was our National Day.
Yes.
So basically 52nd anniversary for the country. So alhamdulillah, it has been a good time, good weather. So I'm glad to see all these people here. Not in July. July is not a preferred month. So yeah, it's a good feeling to see them here.
So let's talk a little bit about a recent Siemens Energy study of 1,400 executives from 22 countries. This fall, it said less than half believe that these countries can meet decarbonization efforts. I think the other part of the key part of this was that very few people believe there are effective strategies in place to do this. So I want to ask you about the role of AI as we've been talking about all evening. Where do you think AI fits into this picture?
So again, in the spirit of COP28, in the
up
spirit of COP28, this transformational efforts of different countries towards this decarbonization, it's a huge effort, and it needs to be taken and looked into in steps. For me personally, and as Siemens Energy, the first, or let's say the quickest win, would be introduction of AI, because with some algorithms, some applications, you would be able to achieve a considerable amount of efficiencies in decarbonizing, let's say, processes. There is a lot of process waste in the energy domain, and by introducing AI modules, you would be able to optimize beforehand, then going into, let's say, changing your hardware. And that's a challenge. Hardware in energy is expensive. It's very capex intensive. So AI would play a good role, a very effective role in expediting this transition journey.
So how is Siemens Energy doing this in terms of employing AI in decarbonization?
So in two folds. Internally, most of our processes in our manufacturing is AI powered, again, to optimize. Our offerings to the energy sector is also have AI aspects in planning, in preventive maintenance, in load management. The colleagues previously talked about microgrids, which is extremely important to be able to manage it. And really, AI is the key. Why? Because of the abundance of data. All of those new technologies generate so much data. And when you have data and you manage your data well, then you have the key to implement a solution. And having an AI-based module would definitely accelerate.
So the Innovation Center in Abu Dhabi is just one of 4 globally that has been created by Siemens Energy. First, can you tell us a little bit about what you all are doing there, and then also particularly why was the decision made to have it in Abu Dhabi?
Yeah, sure. Thank you. So innovation, we do believe that innovation is not a one-man show. There needs to be cooperation and collaboration with parallel industries, with governments, with academia, with research centers. Innovation allows us to think without boundaries, I would say. And when Siemens Energy decided on establishing these innovation centers, we decided on 4 locations to cover pretty much the globe. We have one in the US, one here in Abu Dhabi for this region. We have one in Berlin that covers Europe, and one in China for China and Southeast Asia. Why in Abu Dhabi? The UAE is a country that created a ministry called the Ministry of Artificial Intelligence. So the landscape of innovation is embedded within the new culture of the United Arab Emirates. Moreover, the government is providing funding, support for innovation that would lead and assist in accelerating the journey towards decarbonization. The aspirations of the country is well known. The whole country wants to go net zero by 2050. Our national oil company wants to go even before that, just to set a pace and a commitment towards decarbonization. On top of that, we are located in Masdar City in Abu Dhabi, and Masdar City also houses the Mohammed bin Zayed University for Artificial Intelligence. So that also allows us for a closer collaboration with a scientific beacon of AI.
So we were talking before this event. I'm curious, I would love for you to share your perspective with everyone here. We were talking about OpenAI and sort of the American reaction to everything that's been in the news and headlines. I'm just curious your thoughts on how you perceive what happened there.
Let's limit the application to its uses, right? So today AI is a tool. And if you have the right data and you have the right module, then you will be able to achieve, let's say, the target that you have. A lot of talk about AI that's going to take over the jobs from people. It's going to replace the human element. For me, that's still far-fetched. It's science fiction because we need the human element. We need the new generation of programmers who will be able to take these language modules to the next step. But not only that, we need the application developers. So AI is a tool. Again, I keep on repeating this, and it's up to us how we want to use it and utilize it in the mission that we are embarking into.
And you've been actively involved in efforts to recruit the next generation here in the UAE for workers around not just green energy, but also AI. What are you seeing among the younger generation here and interest in these jobs?
Yeah, so I see a big age gap between me and them, so that's not a very good feeling. But even today, I met a 16-year-old young man, I would say, who is so enthusiastic about this energy transformation and the green future. So it only solidifies in my mind that the solutions using AI and other technologies is going to be driven and carried on by the next generation. They're very conscious and they're very, I would say, environmentally tuned, and it's very refreshing.
What role, so you talked about this, so we talked about sort of the aspirations the UAE has in this space. What role would you like the UAE to see the UAE be playing globally when we're talking about AI and the green technological revolution?
Industries, usually the first obstacle for industries is usually funding. These efforts require a considerable size of amount of funding, and the energy industry does not accommodate for disruptions. Right? So nobody is going to experiment with any technology that might introduce some level of disruption of operations. So governments in general, and specifically for me here in the UAE, what I would look forward to from them is to allow these new technologies to pilot within their infrastructure. Piloting is extremely valuable in terms of testing the data sets into maturing up your AI modules using real-time data and so forth. And of course, funding is always looked at, and I think Sheikh Mohammed on the first day of COP announced a new fund for renewable energy, which is great news for us in technology domain.
Dr. Al-Yafi, we are almost out of time, but I feel like I have to end this evening with you giving us a local perspective on the one thing. I know you're from Abu Dhabi, but if we're not going to make it to Abu Dhabi or just here in Dubai, what you think we shouldn't miss?
Make it to Abu Dhabi.
Okay,
No,
that's your one
but,
fun thing,
yeah,
make it
but-
to Abu
but no,
Dhabi.
Dubai is a culturally extremely rich city. So there is always something for somebody to do. But if you want really, let's say, a UAE experience at this time of the year, we move to the desert. So I would highly recommend that you do some sort of an excursion into a desert, simple desert safari. It's going to be worthwhile.
All right, Dr. Al-Yafi, thank you so much for being here with us.
Thank you.
From Siemens Energy, Chief Technology Officer. Thank you.